our equipment and safety measures are working and in place. When we go to the river and get on our boats, we make sure the boat has no leaks and we have our safety vests on. For young children who are still learning how to swim, we make sure they have their floaters on, or we swim with them in a swim ring to make sure they don't sink. Why is it that boats and swim rings float? There are many factors that determine if an object will sink or float in water, and one of these factors is what we call the specific gravity. The specific gravity is the ratio between the density of an object and a reference substance. The specific gravity can tell us, based on its value, if the object will sink or float in our reference substance. Usually our reference substance is water, which always has a density of 1 gram per milliliter or 1 gram per cubic centimeter. So what is density anyway? An object's density is a measure of how compact or heavy it is in a given volume. We measure density in mass per unit volume, which is written using measures like grams per milliliter, grams per cubic centimeter, or kilograms per liter. Here are two objects with different densities. On the left is an object highly packed with particles. That means it has a high density. On the right is an object with a low density. You can see that the particles are not packed tightly, but that there are fewer particles occupying the same volume. To find the density of an object, we divide its mass by its volume. For example, take an object with a volume of 4 liters and a mass of 1 kilogram. We plug these numbers into the density formula and discover that its density is 0.25 kilograms per liter. The formula for specific gravity, given that the reference substance is water, is the density of the object divided by the density of the water. Here we use the Greek symbol ρ to indicate density. The specific gravity has no unit because the units of the numerator and the denominator are the same, so they just cancel each other out. Let's look at an example. Here, the density of the object is 19 grams per milliliter. The density of water is 1 gram per milliliter. We cancel the unit grams per milliliter because this unit is present in both the numerator and the denominator. The density is directly related to the mass of the object, which is usually measured in grams, but can also be measured in kilograms or pounds. So, the specific gravity can also be determined by dividing the mass of the object by the mass of the water. The mass itself is directly related to the weight of an object.